students, in today's class we are going to discuss the types of the matrices. That too, in that we are going to discuss types of the square matrix. Clear? So the first one I am going to discuss what is meant by symmetric matrix. So any square matrix A is equals to Aij is said to be symmetric if and only if that transpose A transpose should be equals to A. If we have this case, then we can say that a matrix A is a symmetric matrix. So what is the meaning, my dear students? Any matrix A is said to be symmetric if you take the transpose of that matrix, that should be same as the matrix itself. So it means if that satisfies this condition, then we can say that A is a symmetric matrix. Clear? And next one is skew symmetric matrix. So what is skew symmetric matrix? A is a skew symmetric matrix if and only if you take the transpose of this matrix, that should be equals to negative of A. That is nothing but A transpose should be equals to minus A. Then we can say that a matrix A is a skew symmetric matrix. Clear? And next one, my dear students, idiopotent matrix. Up to here we discussed in the board examinations, but now we should discuss what is meant by idiopotent matrix. So my dear students, please remember, idiopotent means any square matrix A is said to be idiopotent if you take the square of that one, that should again give to the matrix A itself. Then we can say that such a matrix A is idiopotent matrix we can call. Clear? And next one is nilpotent. So nilpotent means what? A is a nilpotent of order K. So here it is, it may be 1, it may be 2, whatever. So that means that here it is, generally a matrix A is said to be A is a nilpotent of order K if and only if to that matrix, if you raise with the any constant, that is A to the power K value should be equals to 0. So A to the power K value equals to 0 if you getting means, then such a matrix A is called as A is a nilpotent of the order K we can say. So where K is a least positive integer. So K should be least positive integer. Why means, say for example, if you take one matrix A, here it is, if you take one matrix A, if you square this one, my distance, if you square or if you cube means you may get 0. So now we can say that that matrix A is a nilpotent of order 3 we can say. And in the same way, sometimes A to the power 73 or something, in that case also we may get 0 here. But in that case we should take it as K value should be least integer we should take. Clear? So this is what the nilpotent matrix. So up to here, as I told, we know, but these are some new concepts, my dear students. So please concentrate on that one. Because of this, there are some new concepts will be there. Because of this, I am revising all things. Clear? I know some students may think that we learn all these things directly, they wanted to solve the questions, but sometimes what happens, we didn't discuss this idiopotent, nilpotent, all this we didn't discuss it. So in PUC board syllabus, we don't have this syllabus. Clear? So that's why I am revising the things. And next one is involutory. So involutory means what? Involutory matrix means if any matrix A, if you square means if you are getting the identity matrix. If you have any matrix A, if you square that one, if you are getting that value as I means, then such a matrix A is called as involutory. Clear? And next one is orthogonal. So a matrix A is said to be orthogonal if you take the any matrix A and to that if you multiply with the A transpose, then that value should be equals to identity matrix. If you are getting this, then we can say that A is a orthogonal. A transpose A or A into A transpose you can multiply. If you multiply this value, that should be get it as I, or if you take this 2, if you multiply this, and if you after multiplying this, if you are getting the resultant as I, then also we can say that orthogonal matrix. A matrix A is said to be orthogonal if this condition satisfies. And next, trace of a matrix. So trace of a matrix means what? Trace of a matrix means again, if A is any square matrix, then trace of A is nothing but all the sum of the diagonal elements. If you take the sum of the diagonal elements, then that will give you trace of a matrix. Clear? So that's why I wrote here the summation of AII. AII means that is nothing but the diagonal elements. If you take the sum of the diagonal elements, then we can say that that is nothing but trace of A. If you want, means you can take the example here. It is, if I have any one matrix 1 2 3 1 1 1 1 2 3, if you take this one, then here trace of A is denoted like this. The symbol we will write, usually we will write it as TR, trace of the matrix A. What is trace of a matrix A? Trace of matrix is A is nothing but 1 plus 1 plus 3. So that is nothing but 3 4 5. This is the trace of the matrix A, my dear students. Clear? So this is all about the concept of the matrix. So in the matrix, what should we know? We should know all these concepts. Clear? Briefly I discussed. For more information, you can refer my video, or you can go through the textbook in NCERT. So whatever I discussed in the PUC syllabus, that you can refer. So now I'll solve some questions based on these matrices. Next we will discuss the determinant. After discussing that one, I'll solve the questions based on that one. But as of now, simple questions I'll solve which appeared in our JEE exams, that I am going to discuss. So this is all the basic concept you should know, my dear students. Clear? So next I'll solve the question. So please pause the video, this one, then we'll solve the questions. Yes, my dear students, I wrote the question here. So I'll discuss this question. Please remember, this question was asked in JEE mains exam. They asked in the 7th January to 2020 in the year, and in the first shift this question was asked. Clear? So starting, I'm going to solve the simple questions. I mean, based on the only from the matrices topic, and simple questions these are that I am going to discuss. Clear? So what is the given question is here? If alpha be a root of the equation. So they given you the one equation here, it is. So alpha is the root of this equation, and they given you A. A is a matrix. The value of the matrix A is this much, and then A to the power 31 value is equals to. It means you should calculate the value of here, this A to the power 31. Already they gave you A, matrix A they given to you. We should calculate A to the power 31. Clear? So my dear students, for this one, before studying this question, what they given? Alpha here it is. What is alpha means? Alpha be a root of the equation. So this is the equation given to you. So root of the equation means what? Root of the equation means x square plus x plus 1 is equals to 0. The given that here it is given alpha is root of this equation. Alpha is a root they given, is it? So this is all information you know here it is. Always remember, my dear students, in the question whatever they given to you, that everything is related to the solution. It means they indirectly give you some techniques so that you can hear it is easily. Directly they won't give, indirectly they will give you the information to solve the given question. Clear? So in this question, clearly understand the meaning is, you should calculate the value of A to the power 31. To calculate the value of the A to the power 31, what I'll do, my dear students, first of all, I'll try to convert whether any one among here is either A, or by doing A square, or by doing A cube, or by doing A4. Simply I'll check so whether I am getting any identity matrix or not. Why I should check means, if I get any identity matrix, then by using that I can calculate what will be the value of A to the power 31, isn't it? If I get any identity matrix means, by using that I can easily calculate A to the power 31. So for that reason, what I'll do, first I'll solve the given matrix. I'll calculate the value of A here. A square, A cube, A4, like that I'll goes on check whether I'll get any identity matrix I'll get or not, that I'm going to check. Clear? And another one thing is, my dear students, you should remember here it is, this is here it is. Solution means what? That we should root or solution both are one and same. So root means what? Root means here it is alpha is a root. Alpha is a root means what? Alpha is a root means Here it is, in this, if you substitute here it is alpha, whatever you will get value, that value, solution or root, in the place of x, by substituting in the place of x, if the equation is becoming balanced, then such a values we can call it as a root or solution of the given equation. So we know that here it is cube root of equation, here it is we know that this result, what is that one, 1 plus omega square is equals to 0. So cube root of unity, we can call this as cube root of unity. This result you should remember, very important result, this one here it is. Remember, 1 plus omega square is equals to 0. So this we can call it as cube root of unity, that we can call, or else we can also write it as, we can also have the result omega cube is equals to 0. This you should always remember, my dear students. Clear? So this you may learn in your earlier classes. If not, means just remember this is the result. So what is that one? 1 plus omega square value is 0 and omega cube value is equals to 1. So here alpha is a root they told. What is alpha? Alpha, beta, gamma is the just they told root, but means root they told, but not exact value they given to you. Whether it is 1, 2, 3 like that, exact value they won't give. Just they given you that alpha is a one root of this. So by knowing this result, I can say here it is this alpha value is nothing but it should be, it is nothing but omega only, because we know that 1 plus omega square value is 0. By knowing this direct result, I can say this alpha value is nothing but, it is nothing but omega only. This is the root of this equation. We know this much. Clear? Now by using this one, I'll check the a square value. So I'll check a square. So to calculate a square, what should I do, my dear students? I should multiply a into a. So what is this one? 1 by root 3. Here it is 1 by root 3 into 1 by root 3. Because I am multiplying two matrices a into a. 1 by root 3, 1 by root 3. First I'll multiply, and then the remaining here it is 1 alpha square, 1 alpha square, alpha I'll write into, again this matrix a into a. If you are getting confused, means first only I'll write, because some students may confuse. So therefore a is, what is a? Here it is, a is nothing but this much, 1 divided by root 3 into, again a value. What is again a value? Here it is, again the a value is 1 divided by root 3 into 1 alpha square, 1 alpha square alpha. Clear? So now multiply these two. So now my additions, 1 by root 3 into 1 by root 3. 1 by root 3 into 1 by root 3 is only 3, because we know that root 3 into root 3 is nothing but root 3 whole square. This square get cancels. Since so 1 by root 3 into 1 by root 3 is, it is nothing but 1 by 3. And now we know row and multiplication, we know my difference. How to multiply the two matrices? Row into column. So here it is first row, first column. If you multiply, means what you are getting? Please observe here. 1 1s are 1, 1 1s are 1, 1 1s are 1 you are getting. Clear? Row into column. That is nothing but 1 into 1 plus 1 into 1, 1 into 1 plus 1 into 1. Row into column. Likewise second, here it is 1 into 1, 1 into alpha, 1 into alpha square. It is nothing but 1 into omega plus omega square is equals to. So that is nothing but here it is, this value is, or else I'll write once, here it is first row second column. So here it is 1 into 1 is 1 plus 1 into alpha plus 1 into alpha square. Row into column. Next first row into third column. So what is that one? 1 into 1, that is 1 into alpha square, 1 into alpha, that is nothing but alpha here. Clear? And now my distance, second row first column. So 1 into 1 plus alpha into alpha is alpha square into 1. Is it? Isn't it? So it is 1 into row, second row into first column. 1 into 1 is 1, alpha into 1 is alpha into 1 is alpha, and alpha square into 1 is alpha square. Clear? So like this, second row, this one. So 1 into 1 is 1 plus alpha into alpha is alpha square into alpha square is alpha to the power 4. Second row, third column, 1 into 1 is 1 plus alpha into alpha square into alpha is alpha cube plus alpha square into alpha is alpha to the power, here it is, alpha into square is alpha cube, alpha square into alpha cube it is. Clear. So next, similarly we can write here it is third row first column, 1 into 1 1 alpha square plus alpha, again third row second column 1 plus alpha cube plus alpha to the power 3. Clear. And next this one third row, the third column, so 1 alpha to the power 4 alpha square. My dear students, you can observe here it is this value is nothing but a square is equals to 1 by 3 into, here it is 1 plus 1 plus 1 plus 1 is 3. Here it is 1 plus alpha square. As we told, alpha value is omega. If you substitute means 1 plus omega square. 1 plus omega square value is 0. And here it is again this is 0 because of this one 1 plus omega square. Again here it is this is 0. And here it is 1 plus alpha square alpha to the power 4. Remember alpha to the power 4. Alpha to the power 4 means that is nothing but omega to the power 4. Omega to the power 4 can be written as omega into omega. Omega cube value is, as I told, that is nothing but 1 into omega. Therefore we can write omega 4 value is nothing but, here it is omega. That is nothing but, since omega 4 is equals to omega. Proof I wrote here. Understood? So here it is. Therefore my dear students, remember here it is 1 plus alpha square alpha 4. Alpha 4 value is nothing but omega. It is nothing but 1 plus omega square. Again it is nothing but 0. Here it is. And next one is, here it is alpha cube plus alpha cube, I think it is. Remember here it is alpha cube. What I told, alpha cube value is 1. 1 plus 1 plus 1. That is nothing but 3 here. And similarly here it is 1 plus alpha square plus alpha. That is value is 0. And here it is again it is 3. And here it is again alpha 4 value is alpha. 1 plus alpha plus alpha square value is, again here it is 0. Clear? So this, my dear students, now you can write it as a square is equals to, take the 3 common from this matrix. If you take 3 common, so 3 cancels, 3 ones are 3 ones. So what is remaining? 1 0 0 0 0 1 0 1 0. So therefore this is nothing but 1 0 0 0 0 1 0 1 0. So this is your matrix A. Clear? So what is my aim? My aim is, I should get it as by doing multiplying a with a, a square, whether I am getting a square as identity or a cube as identity, I should check, or a4 as identity, we should check. Clear? So probably I think we will get a4 value. So directly what I'll do, I'll calculate a to the power 4 value. Clear? So you can check a3 also, not a big deal, but my assumption is we may get for the a to the power 4. So for that reason I am checking for a to the power 4. You may check a3 and then you move to the next one, a4. So directly I'll check a4. So what a4 means, how to write, my dear students? A square into a square. So what is a square? Here it is a square value is, here it is 1 0 0 0 0 1 0 1 0. Clear? 1 0 0 0 0 1 0 1 0 into again 1 0 0 0 0 1 0 1 0. Again multiply, here it is, this is nothing but row into column wise. Directly I'll multiply here my dear students. So it is 1 into 1, that is 1 plus 0 into 0 0 into 0. Next, first row second column. So here it is 1 into 0 0 0 into 0 0 0 into 1 0. So here it is 0. Next, first row, here it is first row third column, 1 into 0 0 0 into 1 0 0 into 0. So it is 0. Next, second row first column, 0 into 0 0 into 1 is 0 0 0 1 into 0 is 0. Next, second row second column, 0 into 0 0 0 into 0 0 1 into 1, that is 0 plus 1 is 1. Clear? My dear students, just it is multiplication of these two matrices. You know how to multiply the two matrices, therefore I am writing by multiplying here only. Clear? You should also solve like this only, because if you try to solve as usual method, how will solve in the board examinations, if you solve like that, means that will consume time. that takes, I mean, that takes more time. So therefore better you should multiply like this. Clear? And next second row, third column, 0 into 0, 0, 0 into 1 is 0, 1 into 0 is 0. Next third row, first column, 0 into 1, 0, 1 into 0, 0, 0 into 0, that is 0. 0 into 0, third row, second column, 0 into 0, 0, 1 into 0, 0, 0 into 0, that is nothing but 0. Third row, third column, 0 into 0, 1 plus 1 into 1, 1, 0 into 0, you will get this one. So this is nothing but, here it is, identity matrix. So what I told, first we should check whether a square or a cube or a4, for these values whether I will get identity or not, that we should check. Once if I got as identity, then I can convert this to this A31. What they asked? They asked you to calculate A31. Now my dear students, A31, how can I write A31? I can write it as a to the power 4. A to the power 4 is identity matrix. Identity matrix whole power, how much you can increase the value, always you will get it as 1 itself. I mean identity matrix only you will get. So therefore what I will do, a to the power 4, A31 I can write it as nearer to this 31. 7 I'll write. 4 7s are 30. Here it is 28. So 28 means still how many number I should require to get 31? I mean here it is, how much it is? Cube. 28 plus 3. 31 you will get. It means I should write it as 3. Here it is. Clear? So therefore A31 I can write it as a to the power 4 whole to the power 7 into a cube. Now you can write a to the power 4 means what? A to the power 4 means that is nothing but identity matrix. So identity matrix whole to the power 7 into a cube is equals to identity matrix into 7. Whatever may be the power, again you will get identity matrix only. Identity matrix with the to the identity matrix, if you multiply with the any matrix, you will get the same matrix by which you are multiplying to the identity matrix, the same matrix you will get. Clear? So therefore this is nothing but a cube. So therefore A31 value is nothing but a cube. Then what is the option then, my dear students? The option is, here it is, that is a cube. So therefore the answer is a cube is the your required answer. Clear? So is it understood now? I think now you may got my point. What is my point? My point is I am converting this a to the power 31. Power is so high. To reduce this form, to reduce this one, what I did, I took the use of a to the power 4. Clear? So that's why whenever you have the power like this, try to reduce that one. That will be easily reducible after multiplying a to the a square or a cube or a to the power 4. Within this you will get the idea of the given matrix, how will be the elements that you may get. Clear? So for that reason, if you have the higher power, if they ask the questions like this, means try to convert the given matrix in terms of the identity matrix, so that we can simplify easily. Clear? So this is all about the first question. So we'll discuss the remaining questions in the next video. Please pause the video to note it down, and the remaining questions I am going to discuss in the next video. Thank you.